up, ladies and gentlemen? Enjoy. This will be the last time you see this picture right here because we're finishing section 7 with part 3. And in this video, we're going to talk about how do you write equations given the graph of a piecewise functions. That's correct. We're going to go back and write in slope-intercept form y equals mx plus b. A couple different pieces of that, of course, but we're going to complete the mission with our Mission Impossible and find the slope, find the y-intercept, and create the equations. Write the equations given the graph of a piecewise function. Let's do it. Here we go. So remember, every one of these that we graph, we had ourselves this thing went right down through here, which was the cut line. The cut line went along with whatever it said right here. That's important right there. It said that. And every one of these looked the same. And in this video, guys, what we're doing is this. You're going to be given a graph that looks something like this. Without any of this up here given to you, you're going to take this guy and you're going to rewrite it in this particular form where it's a piecewise function. That's the goal. So here's one like this that we actually rewrote it, or we're going to rewrite back into this guy. Or they look like this. So the point is, these piecewise functions are going to look exactly like that. So let's go. Let's do it. All right, guys. Here's our piecewise function that's graphed that we're going to write the equations that represents the pieces of this particular function. Now, you know it's a function because it certainly does pass the vertical line test, so we're all good to go there. So I'm going to start with f of x. You can use g of x. You can use h of x. It doesn't really matter. I'm using f of x. It's kind of the normal one. That's a weird f. Hold on. Let me go back and do this again. Yucky. So f, that's better. And we know every piecewise function looks like this. We got this little piece here. And we have two different pieces. So there's going to be an equation right here. There's going to be a second equation. And they all have restrictions over a certain domain. So I put if x, x. And now my first thing, guys, if I was you, I would determine what the actual limitations, restrictions, guidelines, aka the borderline, the cut line, what that actually is, what goes over here. So if I go over to the graph, what it appears to me, it looks like right here, where this goes down through there, was my actual cut line. And that's exactly it. Right down, what is wrong? Right down through there, I'm having trouble drawing, sorry. That's where my cut line is. So that happens to be at x equals -3. So over here, my cut line would be -3. So if you're going backwards and I gave you this, you put the dotted line right down through there. Now, I'm going to show you in this example, there's two kind of systems of thought of doing this, but the goal is this. We have to up here write the equation of one of these pieces of this piecewise function. I'll do the easiest one first. And the easiest one happens to be anytime you have a particular piece of the function that actually goes right through the y-axis. That's the easier one because no matter what, guys, here is our ultimate goal. We're writing the equation in slope-intercept form. Oh, it's like the Mission Impossible theme that we did before. So all I have to do is find the slope and I have to find the y-intercept. And this thing in here in the box, that right there is what's actually going to go up there. That's it. So I have to find the slope and the y-intercept of this particular red line right there. And it's the easier one because right away, guys, I see instantly that this particular piece of the function goes through +2 on my y-axis. What does that mean to you? Same thing it means to me. That then would be my y-intercept. So I can do this. I can put y equals, my intercept is +2, so I know that goes in there. The x isn't going to change. That stays exactly as it is. So what I have to figure out now is my slope. Well, I can easily count the slope because if I'm looking at this, and be careful when you do this, I'm going to count the slope by going, let's see, I'll go down 1, that's -1, and I'm going to go to the right 1, 2, 3, 4. There's my next step. No, that's not right. 1, 2, 3. So I'm going to go right 3. So let's make sure that this is accurate. I'm going down 1, that's -1, and then to the right 3, +3. So my slope is down 1 to the right 3. Well, look at that. So there's the equation of that particular red line. So this thing right here, guys, that's exactly bloop, what goes up in here. So I'll take this negative 1/3 x. That looks ugly, sorry. Negative 1/3 x plus 2, and that's what goes up there. Now here's the scoop. That's the actual equation, you betcha. But notice this. I still don't have my inequality symbol over here. I still need to make the restriction. I got the actual borderline, you betcha, the cut line. But I need to determine what side, oh, I see, I got it. So over here to the right is where I've kept my graph. So I want then everything that's bigger to the right of negative 3. So I need to make it this way right there. Now, uh-oh, did you see my mistake? I did it on purpose. Notice this is a closed dot, so therefore I'd have to put a closed, well, if you will, a line underneath it. So now we finally have, yay, star that, smiley face it, woo, box guy, woo, yay. So we have x is greater than or equal to negative 3. That's everything on the right side over here, and that's the equation of that line. Now, we only got one more piece to do. So, let me change colors. I'll make it blue. Let's do this one. Now, here's why this one's trickier. Because you actually don't know, guys, where it goes through the y-axis. So you don't know the y-intercept right away like we did in the first piece. And no, don't you dare guess. If it doesn't go through the y-axis, then you don't know the y-intercept. Sometimes, actually, even though this first one, like it went through the y-axis, sometimes you don't know exactly if it's accurate. It might kind of go like this, where it kind of goes in between. If that's the case, you don't know for sure. So what I just did in the first example might not always work, but this one always will. So here's what you have to do. You can look at this thing right away and say, wait a minute, I know I need to write the equation on this line, so I need y equals mx plus b. I need that. I don't know what the y-intercept is because I don't know where it crosses over here if I kept going with it. But I do know the slope. I can figure that out right away. Watch. I can look at this and say, okay, let's go from here. I'm going to go down 1. It looks like it goes right through that point right there, and it does. So I'm going down 1, left 1. So down 1, left 1. So it's back 1, sorry, down 1, negative 1, left 1. Down 1, back 1, down 1, back 1. So that means I'm actually having a slope of down 1, left 1. So look, my slope then will be negative 1 over negative 1. That actually reduces to just a positive 1x. Now we don't need the positive 1 there, we just kind of write this. So far we got y. We got 1x or just x. What we have to figure out now is what the actual y-intercept is. Oh yeah. So we can at least start with that. Well wait, how in the world would I figure out what the y-intercept is? Oh, I got it. Why don't I just do this? Why don't I just do, let's choose any point that this particular blue line goes through. Any point whatsoever, and plug it in. Plug it in and solve. That's it. Let me erase that. And solve for B. Bam. There you go. So I'm going to plug, wait, what do I plug it into? I plug it into this right there. Because I know my slope is 1x. I know my y-intercept, nope, don't know it. I got to figure that out. So I'll take any point. I could take this point right here. I could take this point right there. I could take that point right there. Any of them will work. Let's just take this point right there. That happens to be negative 5 and negative 1. So I'll take that as my x, and that is my y, and I'll plug it into this equation. I'm going to pull it over here. So negative 5 goes in there, plus b. I don't know what that is. I'm looking for it. And the y value, negative 1, goes in there. So, oh, looky there. Once I plug in my point, my 1, negative 5, all I have to do now is just solve the simple equations for b. That's not too hard. I'll just do this. Add 5, which gives me positive 4. So there is my y-intercept. So what does that mean? Well, that means, guys, I finally now have my equation that represents that blue line. Yes, sir. So that means my equation would be y equals my slope of just a positive 1, up 1 over 1, up 1 over 1, up 1 over 1. Or down 1, left 1, down 1, left 1, down. Same thing. But my intercept is just what I found right here, positive 4. So there The thing in the box, oh, that's the thing that goes up here. That's that piece of the function. And now I just need to determine which way this little inequality goes. And notice, my fold line, my cut line again is right here, so I am graphing everything on the left side of that. Everything on the left side of that, so that's all the stuff that's less than. And notice, it's just strictly less than because it's an open circle. So, ba-bam, there you go. Yes, you need to make sure you go back through and study this one. Do it again. Rewatch it a second time, and then you'll get the idea behind how you find the pieces. But that's all you're doing. You're just finding this piece right here, finding the graph. It goes right through the y-intercept. Plug it in, and you find the slope by just counting. Very simple. And then that goes in the first one. And then determine which way you're going over here with the actual inequality. And then go do it again. Repeat the steps. So but this one's different because it doesn't go through the y-intercept, but you can immediately find the slope. So plug that in, and then use that equation to find any other point. So choose any point that goes through that thing, any point that the line goes through, any point, and then plug it in over here, which will then determine your y-intercept. Piece everything together, put the slope in the y-intercept, and you got it together. That's it. There you go. Excited to do this stuff in class, and rock and roll. We'll see you later.